Potential energy is stored energy based on its position. For example, an object that's lifted above a desk will have potential energy relative to the desk. If the object is placed flat on the desk, it won't have any potential energy relative to the desk. Gravitational potential energy equals mgh. The potential energy of gravity is measured in joules, or J. The m stands for mass, which is always measured in kilograms. The g is gravity, measured in meters per second squared, and the h is height, measured in meters. Okay, so let's look at an example. The first one reads, a 6.3 kilogram box is held 3 meters above ground. What is the gravitational potential energy? So let's first look at what we know. We know that the mass is 6.3 kilograms, the height is 3 meters, and gravity is always going to be 9.8 meters per second squared. So to solve this, you just basically plug in all the knowns into the equation, gravitational potential energy equals mgh, and when you multiply them all together, you get 185.22, and that's going to be measured in joules. Okay, so now let's look at the potential energy of a spring. Hooke's law says that a force is needed to extend and compress a spring a distance is proportional to the distance. The equation for this is going to be potential energy of a spring equals 1/2 kx squared. Potential energy of a spring is measured in joules, which is denoted by a capital J. The K stands for the spring constant, which is measured in newtons per meters. The x is going to be the distance, which is going to be measured in meters. Let's look at an example for the potential energy of a spring. Okay, so it reads, a spring is stretched 0.5 meters from equilibrium. The spring constant is 1,500 newtons per meter. Find the potential energy of the spring. So to do this, we're going to first start off with what we know. We know that x, or the distance, is 0.5 meters, and the k is going to be 1,500 newtons per meter. To solve this, you're basically going to take all your knowns and plug it into the equation, potential energy of a spring equals 1/2 kx squared. So when you multiply all those together, you're going to get 187.5, which is measured in joules. There is a way to mix the two equations. Basically, all you do is set them equal to each other, as in mgh equals 1/2 kx squared, and then you just isolate whatever variable you're looking for, and that's about it.